Well, hello and welcome everyone to this Deprag webinar. Deprag manufactures automatic assembly equipment and screw driving machines for many different industries. Its systems range from affordable handheld screwdrivers to fully automatic advanced assembly machines. Manufacturers use Deprag equipment to assemble fasteners into many different products, such as electronics, medical equipment, white goods, telecommunication equipment, transportation equipment, and many more. The Deprag screw driving equipment is made to specification and therefore allows the best possible solution to difficult applications that require state-of-the-art engineering and design for a successful assembly. You can learn more at depragusa.com. Okay, now moving on with our presentation. In this slide, the general sequence of fastener rundown is explained. Now, it's important to remember that even within each step, several different changes occur to speed, force, etc. The 6 basic steps are heating up the point of penetration with high force and speed, then the penetration of the screw location, which now requires a reduction of force and speed, the funnel forming where an optimum speed is absolutely necessary, the thread forming where the force needs to be held to a minimum to avoid thread damage, then the screw driving, where it is critical to use the correct torque and speed for the fastener to be driven, and finally the tightening, where the fastener is seated without damage to thread or fastener and for optimum head flushness. Here are some advantages. This chart clearly shows that the adaptive DFS is uniquely suited for all types of different joining methods, such as access, disassembly capability, clamp force, etc. Only an assembly system such as the ADFS allows for all the different joining methods of sheet metal and other material combinations. Deprag has already supplied many different industries with this revolutionary assembly system, namely the automotive, white goods, and container building industries. The closed-loop system of the Deprag ADFS has enormous advantages over an air cylinder, since the thrust is fully controlled. Why is an EC servo actuator better than a pneumatic cylinder for the feed stroke? The closed-loop system of the ADFS features an EC servo actuator versus the commonly used air cylinder for the feed stroke. This is a major advantage since the air cylinder tends to have its air expand regardless of how quickly counterreactions are released. That leads to an inaccurate control of the applied force and may result in poor funnel forming or delamination during assembly of composite materials like carbon fiber. It also may recognize the point of penetration too early or too late. There's not accurate control. That also means that extensive adjustment efforts are needed for the parameter settings, resulting in downtime for changeovers between slightly different screw batches or material properties. By using an EC servo actuator for the feed stroke, there is a complete adjustment capability, and the system actually automatically adjusts to actual assembly conditions. Now, different screw batches or varying surface materials are absorbed and automatically processed. The adjustment effort or parameter change requirement is totally minimized. This timeline shows that the assembly of a flow-form fastener requires about 2 seconds. The process parameters are updated on demand and assure an optimized process. This process allows that many different fasteners can be assembled with the new system. The system is actually capable of being changed from one fastener to the next. Those fasteners could be any of the flow-type fastener families as long as the head geometries are the same. Those fasteners include flow form, flow point, or flow push. Since the point of penetration is automatically recognized, the remaining time, T, is maximized to optimize the forming process. The other components of the timeline are shown as well. Okay, to help illustrate and reinforce some of the material we have just discussed, we'd like to show you a 3D video rendering of the Deprag adaptive roboter in action. This slide shows the different core components, including the DPU 200 controller, showing the listed advantages, the EC screwdriving system, and a feeder for transportation of the fastener. The DPU 200 incorporates a 15-inch display and is designed to work with a Windows 7 Ultimate operating system. For easy access, connection, and maintenance, the DPU 200 is housed in a convenient standalone control cabinet. Deprag offers several different types of feeders that speed up the transportation to the screwdriving system. Those feeders could be vibratory or sword feeders with additional supply hoppers. In this slide, we see some technical data. The speed of 8,000 RPM and the maximum seating torque capability of 15 Newton meters or 133 inch-pounds, as well as the allowable force of up to 3,000 newtons or 675 pounds of force, assure that a wide array of applications can be handled by one system. The lightweight construction of only 77 pounds makes it possible to use this screwdriving system with many different robots that have smaller footprints and require less payload. This sketch is a rendering of the standard screwdriving system, showing its compact dimensions and layout. Through the years, Deprag has developed many different controllers to suit industrial applications, such as screwdriving, assembly, feeding, cycle control, statistical processing, and much more. The controls are also simplified to allow an easy handshake with the robot itself. This is accomplished either through a bus or I/Os. Again, extensive data exchange is possible. The standard DFS is designed to allow the connection to the robot through either the rear or from the top. Let's take a look at the human-machine interface. The main menu of the HMI interface shows the available settings in one clearly to understand and easy-to-use screen. The main options are Programs, Settings, Results, Service, Info, and Maintenance. The versatile software options allow the operator to custom design his own screen showing required results. The software is offered to operate in 13 different languages and allows for user administration and changes to system settings. We identify 10 major features, from the advanced screwdriving process to the controlled thrust, which is downforce, to the embedded pneumatics and the I/O distribution, the quick change feature of the mouthpiece, the locking stroke for inverted assemblies, special gadgets for commissioning and documentation, feeding principle of head first, which avoids damage to the tip of the screw, the actively controlled jaws, which positively hold, center, and guide the screw, the different screw feeding options via feed hose or by magazine, to the maintenance friendliness that supports the operator. These features are all part of what makes this assembly system so revolutionary. Okay, so why adaptive? The adaptive process has the following advantages and avoids commonly occurring errors that are very expensive to detect and fix. Avoids seizing of screw and optimizes funnel forming. Avoids thread damages and puts less stress on fastener and product. Guarantees the shortest possible cycle time and reduces setup time with regards to parameters and analysis. Guarantees a high process stability with less faulty joints. Is already prepared and able to assemble new materials, fasteners, and joining methods. A center axis thrust means the direct transfer of thrust onto the screw without lateral forces on the guide mechanism, etc. It also allows for a lightweight design, which helps with robot selection, and it also reduces wear and tear of important components. All pneumatics, sensors, and electronics are fully integrated, which results into short reaction time. The bus interface is routed directly to the DUP, and the clean surfaces avoid hang-up or external damage. The mouthpiece assembly can be exchanged without any tools. Simply press the release button and remove the complete assembly. There's no need to disconnect any cables or hoses. This feature allows a fast changeover to different tooling or if maintenance is required. If the assembly is in an inverted plane or underfloor, then the screwdriving system incorporates a locking stroke. This stroke moves the bit/socket into position behind the screw head and keeps the screw stationary. It cannot be pushed back into the tooling or fall back into the tooling due to gravity. The system is configured to allow the add-on of special components during commissioning. Such a component could be a laser pointer or a vision system. The system is designed to accept these gadgets without necessary redesign or rebuilding. Now, another tool is an adjustable tripod, which helps you with manual alignment procedures for curved surfaces. It also mounts to the quick change feature. These fasteners for flow drill, flow form, or flow push assemblies are precision components, and damage to the tip could result in a joint failure and expensive rework. Our head-first feeding feature eliminates stress on the screw shaft and especially on the screw tip, which is needed to drill through material. This feature also allows for a fast reload time, since the screw is basically sitting already in the buffer in which another screw is being assembled. The optimized cycle time speeds up production. The nose piece jaws are cylinder activated. This means that they are operating only when needed, and that time is perfectly coordinated with the assembly controlled opening sequence. Active jaws have shown to reduce wear and tear on the jaws themselves, resulting in low maintenance and upkeep, and they perfectly align the fastener, which is always perpendicular to avoid cross-threading, etc. Deprag offers different ways to get a fastener to the screw driving system. One of the most commonly used methods is the feeding through a feed hose. While this is one of the fastest methods, it may also happen that the feed hose kinks or can damage its geometry in a way that screws are getting stuck during the reload process. This will cause interruption of the production run, impairment of the process reliability for the overall system, and will result into considerable debugging expenditure. Now, another advantage of the magazine feature is that we eliminate the feed hose altogether and do not add to the already expansive cable dressing on the robot. Deprag has taken great pride in designing a screw driving system that keeps the operator in mind and helps minimize maintenance. This has resulted into a modular design with quick change features for bit, socket, mouthpiece, downholder, etc. The system offers trending information in regards to duty cycle, updates on maintenance interval requirements, and calls out replacement timing for wear and tear parts such as bits, timing belts, etc. There's an active feedback on the required calibration intervals as well. The system is rather intuitive and custom maintenance instructions can be implemented. It also allows individual configurations through cable extensions and connectors. The modular design is not limited to the tooling itself, but runs throughout the complete system, including drive, motors, housing, etc. This modularization is achieved by using quick change adapters and plug-in connectors between the different modules. Software maintenance. The ease of maintenance not only pertains to the individual components, but to the software as well. Software results. This allows graph overlay of the trending analysis and the simple archiving of results and parameters. Integration, hookup, connection. The complete DFS is equipped with quick change connectors for all relevant connections. That allows the fast removal or exchange of the complete unit. Deprag has also taken great pains to customize the cable configuration so that a customer has many different options when it comes to the cables he or she prefers. Okay, so we've covered a lot of material today, and at this point I'd like to show you a 3D video rendering that combines all the advantages of the adaptive DFS in a viewer-friendly format. So let's take a look. And with that, we're going to have to wrap up today's webinar. We'd certainly like to extend a special thanks to Deprag today for all that great information. And if you'd like to learn more about Deprag, just go to depragusa.com. Thanks again, take care, and have yourselves a great day.